Hello students, welcome to my YouTube channel Integrated Physics Studies IPS. एथिरे मु ऑलरेडी प्लस टू सेकेंड ईयर सिलेबस कंप्लीट कर सारी एबे मु प्लस थ्री CBCS फिजिक्स ऑनर्स जीई आ MSc फिजिक्स ऑनलाइन क्लासेस रो वीडियोस अपलोड करुच्ची जदि भल लगिला ताले वीडियोस को लाइक कर देबा और चैनल को सब्सक्राइब कर देबो यू कैन शेयर इट विथ योर फ्रेंड्स आल्सो इट्स कंप्लीटली फ्री ऑफ कॉस्ट लेटेस्ट वीडियो नोटिफिकेशन पई बेल आइकन को एठी ऑल रे सेट कर देबो तापरे वीडियोज रो क्लैरिटी बढ़ावा पई गो टू सेटिंग्स क्वालिटी एडवांस उपरे क्लिक करी यू कैन इंक्रीज द रिजोल्यूशन सबू वीडियोज पाई पीडीएफ नोट्स मु पठेबी जोटा एठी ड्रॉप डाउन लिस्ट को क्लिक करी यू कैन गेट द लिंक फ्रॉम द डिस्क्रिप्शन बॉक्स तापरे मोर चैनल नेम को क्लिक कले सबू वीडियोज को मु यूनिट वाइज एच पार सिलेबस सजाई की रखिथिबी व्हिच यू कैन गेट फ्रॉम द प्लेलिस्ट एठी सर्च करि परिबो ओके थैंक यू हेलो स्टूडेंट्स आज रो टॉपिक रे हमें मोशन ऑफ ए हेवी सिमेट्रिक टॉप अंडर द एक्शन ऑफ ग्रेविटी ए विषय रे पढिबा सो जदि गोटे टॉप माने ओडिया रे कहले नटू ओके ताकू जदि आमे डिस्कस करूछु एप्रोक्सीमेट याकू करि परिबा टू ए वेराइटी ऑफ रिजिड बॉडीज लाइक अ चाइल्ड टॉप ओके पिला ने जेमती नटू खेलंती तुम देखिथिबो किबा गोटे जायरोस्कोप ओके and it pivots around a fixed point, suppose O, on the symmetry axis, and we take the distance of this point O from the point G. G hegala yara center of mass. Let us take the distance to be small l. Okay, and taking the body Z dash axis to be the symmetry axis and as the principal axis, let us put the moment of inertia I1 equal to I2. Okay, that means the only force acting on the top is the force of gravity, which is the product of mass into acceleration due to gravity, that is mg, and it is acting at the center of mass g downward. Okay, let us analyze the same thing here as shown in the figure. Okay, जोटा हमें देखुतिला here, this is the shape of a top, right? So it is center of mass which is a point which is G. This is mg which is the weight acting downward. Now this is Z dash axis which is the body set of axis and the symmetry or principal axis, right? Now Euler's angles जदि आमे देखिबा एठी देखो एठी आछी थीटा एटा आसीगला साइ एठी आछी फाइ ओके फाइ थीटा आउ साइ. So these three Euler's angle will be most convenient set of generalized coordinates in order to describe the motion in this case of a heavy symmetric top. So एथिपाई आमे कोन करिबा यारो Lagrangian बाहर करिबा. Lagrangian आमे जानिचु kinetic energy minus potential energy. So in this case the Lagrangian L is equal to T minus V. So एठी आमे पुट कर देला half I1 omega x dash square plus omega y dash square plus half I3 मन रखो I1 is equal to I2 आमे नेचु then half I3 omega z dash square एटा आसीची kinetic energy minus the potential energy is mgl cos theta. Okay, so एबे जदि आमे angular velocity को in terms of Euler's angles लेखिबा आउ तार जो वैल्यू पाइथिला आमे आगरु ताकू सब्स्टिट्यूट कले Lagrangian रो वैल्यू टा ए हिसाब रे देखिबो. ओके एटा डायरेक्ट रिलेशन लिखिछि याकू डेराइव तमे करिवो. ओके ए हिसाब रे आमे Lagrangian पाइ जिबा. सो हमर एम होउछि our aim in taking up the present discussion is to deal with the interaction of various types of motion that top the executes. Okay, ए जो टॉप बा नटुटा को हिसाब रे विभिन्न प्रकार मोशन एग्जीक्यूट करूची से ताकू हमें डिस्कस करिबा. सो as we know that apart from translational motion, simple way रे कहले translational motion को हमें छाड़ी देबा, the top can have following three types of motion. गोटे हला precession, गोटे nutation आ गोटे हला spin. Precession माने कोन? It is the rotation about the space z axis and such a rotation correspond to angle phi, that is one of the Euler's angle. Then nutation, which is the rotation about the intermediate x1 axis or the line of nodes, and it will correspond to angle theta. another Euler angle, and the spin is nothing but the rotation about the body z dash axis, and such a rotation correspond to the third Euler angle, that is psi. And here the spin velocity about the z dash axis is omega z dash, which is given by, in terms of Euler's angle, that is phi dot cos theta plus psi dot. Okay, এটি দেখো এই যে angular velocity র value লেখা ହେଇଛି in terms of Euler's angle. Now moving further, therefore we shall take off different cases, okay, one by one ଆମେ ନେବା. Okay, for example, to see how precision is affected when the nutation is absent or when nutation is present, କେମିତି precision ଟା affect କରୁଛି. Okay, obviously nutation correspond to motion of the body z dash axis between two angles of theta, that is theta 1 or theta 2 ভিতরে in the z dash y dash plane as shown in the figure. Okay, আচ্ছা, now as the precision about z axis is present, the motion of z dash axis from suppose theta 1 to theta 2 or vice versa will not be confined in a plane. Okay, so plane suppose ଆମେ ଯଦି ନେଇଗଲା z dash y dash, ଏଇ plane ରେ ଏଟା confined ହେଇକି ରହିବ ନାହିଁ, right? ଆଚ୍ଛା, ୟାକୁ ଆମେ detail ଆକୁ ଦେଖିବା. Okay, but it will be delineated. Okay, that is the z dash axis will trace out a curve. Okay, detail ଆମେ ୟା ବିଷୟରେ study କରିବା. Okay, ଯେତେବେଳେ ଆମେ particularly precession then nutation ଏଇ ବିଷୟକୁ ଯିବା. Okay, while moving from theta 1 to theta 2 or vice versa, जोटा कि ଆମେ upcoming figures गुड़ारे देखिबा. So first integral equation let us derive. Okay, so Lagrangian ଆମେ already पाइगला in terms of the Euler's angles. Okay, so ସେଥିରେ ଆମେ ଦେଖିବାକୁ ପାଇଲା ଯେ that was not containing, it does not contain the Euler's angle, that is psi and phi, and also time t. Okay, that means we can say they are cyclic coordinates. Okay, and hence the corresponding momenta p psi, p phi and time ସହିତ ଆମେ ଜାଣିଛୁ energy associated, so total energy E will be constant with respect to time, right? So these three integrals of motion याकू एबे हमें express करि परिबा p psi, p phi. Okay, ताले यार value accordingly i1 alpha, sorry i1 a and i1 b suppose हमें पाइला. Okay, अच्छा, एठी आमे b को नउछु गोटे constant, a मध्य गोटे constant, ताले t plus v kinetic energy और potential energy which is nothing but the total energy, एटा भी मध्य हमें value पाई गला. अच्छा, equation 2 और 3 को हमें solve जदि करूछु for the value of psi dot and phi dot, it will give you the value like this. Okay, you can solve. After solving you put the values in equation for the energy. Okay, তাহলে energy equation তে E dash which is E minus this much. Okay, this term will come out to be like this. Okay, equation 7 ହେଲା, and this equation when solved for theta as a function of time t, then it will involve the use of elliptic integrals which tend to introduce complexity. Okay, complex आड़कू एटा पड़ेबो. Therefore some other ways must be found which may describe the phenomenon quantitatively. Okay, and one of the such way is that of the effective potential which is occurring in equation 7 and is a function of theta alone. So एठी हमें निगला गुटे effective potential v prime by v dash which is a function of obviously theta to be equal to this much. Okay, माने एतिकी जो term टा, right? And this is a one dimensional problem in the theta coordinate. Okay, so याकू जदि आमे फिगर रे बुझिबा in figure 6.12a. Okay, upcoming figure को मु जाउची एठी देखो this one. Okay, so here in this figure 6.12a we have plotted the effective potential along the y-axis as a function of theta, right? So v dash theta assumes to be infinite. ओके यार भैल्यूटा इनफाइनाइट हेबो फॉर थीटा इक्वल टू 0 देखो एटा इनफाइनाइट आड़ को जाउची ए जो कर्वटा ऊपर को जेतले जाउची राइट एंड also its value will be infinite at theta equal to pi pi आड़ को भी एटा infinity आड़ को एटा अप्रोच करूची a finite value रहुची for all the values lying in between them okay so it follows that for some values of theta in between 0 to pi its value will be finite right so let us say v dash assumes a minimum value okay at a point where theta equal to theta 0 okay and this minimum must therefore be the solution of the equation okay equation जोटा आमे पाउथला तार सॉल्यूशन टा ए मिनिमम वैल्यू टा निहाती भाव रे हबो सो हमरो जो v डैश इक्वेशन थिला पुनी वापस से इक्वेशन को जीवा हमें देखो this one okay এই जो इक्वेशन थिला जदि मिनिमम काढिबा that means we have to differentiate this v dash with respect to theta and equate with 0 okay ताले सेया करा जाऊ देखो differentiate कला हमें equate करूछु हमें 0 सहित and thereafter we solve it okay now for a particular value of energy which is E dash equal to E minus this much theta motion is a bound motion and confined between the two values of theta that is theta 1 and theta 2 which are nothing but the roots of this equation okay so here E dash equal to V dash theta or E dash equal to यार value टा हमें put कर देला okay so the variation in the angle theta referred to as nutation of the symmetry axis of the top and is an up and down motion of the symmetry axis okay but however the minimum effective potential equals the energy E dash and the angle theta keeps fixed at a value theta 0 जो जगह minimum रहुची and the top precesses with a constant angular velocity which is given by phi dot यार जो value टा हमें पाइथिला equation 5 रे okay so this angular velocity is kept constant about the vertical axis okay अच्छा तापरे next देखिबा हमें precession without nutation तेबे ता पूर्वरु ए जो थीटा रो वेरिएशन को हमें जदि फिगर रे देखिबा अगेन वी गो टू द फिगर दिस वन देखो एटा हमरो लाइन ऑफ नोट्स आछि दिस इज आवर एंगल फाई नाउ थीटा रो जो वेरिएशन एटा हला थीटा 1 एटा हे गेला थीटा 2 आ ई मझी रे रहउची ए जो छोटिया एंगल ओके दिस वन दिस एंगल इज थीटा 0 okay where we have found out the effective potential to be having minimum value right okay now coming back precession without nutation so we shall calculate the angular velocity of precession and spin when the nutation will be absent that is z dash axis remains fixed at theta 0 then from equation 9 it is obvious that for a given theta 0 there will be two angular frequency of precession that is phi 0 dot okay and it is given like this এটা equation 9 ରୁ ଆମେ ପାଇବା okay thus the corresponding to positive sign of the radical the precession will be fast while corresponding to the negative sign precession will be slow okay because phi 0 dot must be a real quantity so the quantity under the radical sign should be kept positive definite that means এই जो i3 स्क्वायर साइ डॉट स्क्वायर माने এই जो स्क्वायर रूट ভিতরে जो क्वांटिटीটা আছে ओके दिस मस्ट बी आइदर ग्रेटर देन 0 और इक्वल टू 0 ओके सो यार देखो गोटे कैलकुलेशन जदि आमे देखिबा जोटा कि डायरेक्टली कैलकुलेट करा हितला ए जो तमरो मिनिमम करला परे फर्दर कैलकुलेशन करिकी phi dot 0 square and so on यार quadratic equation बाहर करा जाइछि in terms of phi 0 dot okay जो थ्रू कि हमें रूट्स पाउछु okay से जा भी हो मूविंग फर्दर सो आमे देखिला जे psi dot square यार वैल्यूटा निहाती भाबरे आइदर real habo niyati bhave real habo, so that its value must be greater than or equal to this quantity. Thus this equation limits the value of psi dot for which the steady precession may occur at the angle that is theta 0. And further, we can also solve this equation 12 for phi 0 dot in terms of omega z dash, so that the angular velocity about z dash axis, which will be called as the spin angular velocity, given by this equation. Okay, यार भी solve जदि तुम करि परिबो, लास्ट देइछि बही रे देखो तले एठी अछि सॉल्यूशन देखो. ओके, ये जो स्टार मार्क देला माने यार सॉल्यूशन को ये तले एंती करि थाए. ओके, ए इक्वेशन हमें पाई जाउछु अगेन क्वाड्रेटिक इन phi 0 डॉट, राइट. अच्छा, तापरे पुटिंग द वैल्यू ऑफ phi 0 डॉट फ्रॉम इक्वेशन 5 रे जो phi 0 डॉट रो वैल्यू हमें पाइथिला ताको हमें एची पुट कला एंड वी सॉल्व इट फर्दर. Okay, and we note that the value of theta 0 is when less than pi by 2, then the physical motion is possible, and as stated previously, for uniform precession the quantity under the radical must be positive. That means this quantity must be greater than or equal to 0. That means omega z dash minimum will be equal to square root of this quantity, and this is the minimum spin angular vector, which is the velocity, angular velocity omega z dash, below which the top cannot precess uniformly. Okay, omega z dash ru कम जदि हेगला आमर angular velocity ताले आउ uniform precession top देखि परिबो नाही at the angle theta 0. Okay, and it is given by equation 15, this one. Now similarly, when omega z dash is greater than omega z dash minimum, then this quantity under the radical will not be 0, and hence there will be two values of phi 0 dot, okay, given like this. Okay, and it is the slow precession which is ordinarily observed with a rapidly spinning top. Okay, गोटे नटु बहुत जोर घुरुची ताले स्लो प्रिसेशन देखैबो, जोटा कि तमे देखुथबो बहुत जोर घुरुची नटुटा किंतु प्रिसेस करथबो. ओके, से जा भी हो, एठी होची लार्ज वैल्यू ऑफ एंगुलर वेलोसिटी ओमेगा जेड डैश. तापर नेक्स्ट केस हला न्यूटेशनल मोशन. Okay, nutational motion. So let us now investigate the nutational motion that we have mentioned earlier. So at the angle theta 0, the effective potential V dash theta, यार value हमें देखिला minimum रहुची, and it corresponds to a point of stable equilibrium. Okay, stable equilibrium रे हमें जानिछु potential energy रो value minimum रही था. Now theta 1 theta 2 एटा हमें देखुथिला जो limit theta रो. Okay, so these two being the turning angles corresponding to the effective energy E dash, and it follows therefore that the situation exists for which the nutational motion of the axis of the top can be described as a frequency of these oscillation, and is given by this equation omega theta यार value हेगला this much. ओके, केमती यार वैल्यूटा आछी देखो एठी डेराइव करिछि. ओके, एटा नै गला पोटेंशियल एनर्जी या को टेलर एक्सपेंशन करला. तापरे हमें ए जो फर्स्ट वन एटा तो 0 हबो मिनिमम जेतु अछि. तापरे यार वैल्यू जेमती तमे क्लासिकल मेकानिक्स स्मॉल ऑसिलेशन रे करथलो सेही बडा ही रहइबो. तापरे या ए वैल्यू को हमें 0 नेबा at the equilibrium position because it is the stable equilibrium position. So we are left with the third term, and we neglect the higher order terms. So it third term को हमें नेला half d square v by dx square into x minus x0 square, and we try to solve it further and getting the value of omega theta like this. Okay, अच्छा, so इस हिसाब रे omega theta रो value हमें पाउछु. Moving further, we find that the second order derivative of the potential, that is d square v dash by d theta square, coming out to be this much I1 into this much. Okay, and here the angular frequency of oscillation about theta 0 obviously depends on the spin velocity, that is omega z dash through a and on phi 0 dot. Okay, so this motion is delineated by the precessional angular velocity, that is phi 0, which is dictated by the spinning velocity omega z dash, and it is customary to depict the motion of the top by tracing the curve of the intersection of the figure axis means symmetry axis on a sphere of unit radius, and this curve is then the locus of the figure axis. Okay, so polar coordinate যদি আমি use করছি, polar coordinate of a point on the locus are identical with the Euler's angle, that is theta and phi, because polar রে ଆମେ ନଉଛୁ r theta phi, so ଏଠି theta ଆଉ phi match କରୁଛି Euler's angle ସହିତ for the body system, body coordinate system. So the bounding angles, that is the limiting value of theta, theta 1, theta 2 on the unit sphere satisfy the equation 10, and when E dash equal to V dash, in which ଆମେ ଦେଖୁଥିଲା momentum p phi p psi ଆଉ energy E, which are determined from the initial condition. Okay, now if we multiply this equation by sin square theta, it will become a cubic equation in cos theta. Okay, so figure 6.12a କହିଲା. Okay, again ମାନେ ସେ ଯୋଉ ତମେ effective potential ର plot ଦେଖୁଥିଲ with respect to theta. Okay, same figure ରେ there will be now two real roots, that is cos theta 1 cos theta 2, ଆଉ ଯଦି cos ର value ଆମେ ଦେଖିବା ଏଟା range करे -1 ରୁ +1 ଭିତରେ. Okay, so the third root can in fact be shown to be greater than 1 on considering equation 10 and is not of physical interest. ତେଣୁ ୟାକୁ ଆମେ neglect କରିବା. Initially when the top is spinning fast, the nutation motion is absent, and initial condition रे cos theta 1 equal to cos theta 2 equal to cos 0. Okay, where the potential energy is minimum, and if initially theta dot equal to 0, then initial value of cos theta 1 and of your cos theta satisfies equation 10. During the nutation, the precessional velocity varies in accordance with equation 5. Okay, if the magnitude of b is less than a, मन रख b ଆଉ a आमे constant जोटा replacement नहीं थिला. Okay, so if magnitude b less than a, or we can say the momentum of phi is less than momentum psi, माने p phi less than p psi, then we can define the third angle, which is now theta 3, as cos theta 3 equal to the ratio of the momentum now p phi by p psi, which is nothing but equal to b by a. Okay, so in view of equation 5 जोटा कि phi dot रे equation थिला, जदि आमे नौचु theta को greater than theta 3, then phi will have the same sign as omega z dash, and যদি theta is less than theta 3, then it will have opposite sign. Okay, also dv dash by d theta will be negative, that is the slope of the potential curve जोटा कि हमें पाउथला will be negative. Okay, and the angle between the tangent to the curve and theta axis will be greater than 90 degree. So consequently theta 3 will be less than theta 0. So in this way we can have three numbers of cases. Number 1, if theta 3 less than theta 1, ताले the value of phi dot will be having the same sign as that of the angular velocity omega z dash throughout the nutation, and the figure axis will trace out a curve as shown here in the first figure. Okay, so this is actually a unit sphere. A unit sphere रे जो curve तैयारी हबो एई भलिया. Okay, so this is our theta 3, this is theta 1, and this is theta 2. You can see एठी जो arrow mark दिया ହେଇଛି. Okay, here arrow mark এটা সমান direction রে ଅଛି, so that phi dot is having the same sign as that of the angular velocity omega z dash, right? So here এই जो curve ଆମେ ପାଉଛୁ ୟାକୁ ଆମେ କହିବା ଏଇ जो ଆମେ motion ଟା ଦେଖିଲା top ର ୟାକୁ କହୁଛୁ theta motion. Okay, so here the variation in the angle theta is referred to as the nutation of the symmetry axis of the top and is an up and down motion of the top. Okay, ये गला first case. Second case, if theta 3 is greater than theta 1, এটা ଦେଖଉଛି second figure, ताले एबे phi dot ର value ଯଦି ଆମେ ଦେଖିବା it will now change sign, okay, it will change sign। so ଦେଖ ଏଠି arrow mark ଏପଟେ ଗଲା, okay, indicating left, କିନ୍ତୁ ତଳେ ଦେଖ indicating right, okay, ଏଟା ଆସୁଛି theta 1 3 and 2, okay। so the value of phi dot, as I said, it changes sign during the nutation, thus the nutational precessional motion is now a looping motion। या भितर देखो looping होची, okay, looping create होची बा loops create होची, okay, so it is a looping motion of the symmetry axis on the unit sphere, okay। and finally third case रे if theta 3 is equal to theta 1, okay, equal to theta 1 माने एठी हमें simply देखिबा जे theta dot और phi dot ର value 0 होइजिवो, they vanish, and the resulting motion of the symmetry axis on the unit sphere is ए जो shape देखौची curve, याको हमें कहबा cusp like motion, okay। so these are the three cases, okay। moving further, let us now discuss some of the special cases of the motion of the heavy symmetric top। प्रथमे ହେଲା fast top। ତେବେ ତା ପୂର୍ବରୁ ଗୋଟେ ଜିନିଷ କହି ରଖେ, motion of a heavy symmetric top କହିଲେ generally nutation ଆଉ precession ଉପରୁ ହିଁ question ଆସିବ, okay। ଆଉ fast top ଏଟା ହଉଛି ଗୋଟେ special case यार। similarly ଆଉ ଗୋଟେ second special case ଅଛି sleeping top, okay। so ମୁଁ यार detail calculation को ଯିବିନି, okay। so first of all fast top କହିଲେ କ'ଣ, obviously it will be a top which is spinning very rapidly about the figure axis, suppose with an angular velocity omega z dash। তাহলে এই কেস রে আমি ইনিশিয়াল এঙ্গেল থিটা ইকুয়াল টু থিটা 1 নেইগলা ଆଉ ইনিশিয়ালি এটা রেস্ট যেহেতু ଅଛି, so theta dot 0 phi dot 0, so we are left with the spinning angular velocity that is omega z dash which is equal to psi dot or psi 0 dot। accordingly ଆମେ ଯେମିତି ପ୍ରିଭିୟସ୍ କାଲକୁଲେସନ୍ କରିଥିଲା ସେଇ ହିସାବରେ ଯଦି ଯିବା ତାହେଲେ ଏ ବି ଆଉ ଇ ଡ୍ୟାସ୍ର ଭ୍ୟାଲୁ ପାଇଗଲା, ଓକେ। ଦେନ୍ ଆଉ ଡିଟେଲ୍ କାଲକୁଲେସନ୍କୁ ମୁଁ ଯାଉନି, ଓକେ। ସେମ୍ ଇକ୍ୱେସନ୍ ଏଠି ଆମେ ଆପ୍ଲାଏ କରୁଛୁ। ଦେଖ ଏଠି ଯେଉଁ ପୋଟେନ୍ସିଆଲ୍ ଏନର୍ଜି, ଓକେ, ফার্স্ট ଆମେ ଦେଖିଲା ଷ୍ଟେବୁଲ୍ ଇକ୍ୱିଲିବ୍ରିୟମ୍ ପୋଜିସନ୍ ଅଛି, ସୋ ଫାର୍ଷ୍ଟ ଅର୍ଡ଼ର ଜିରୋ ଅର୍ଡ଼ର ଏଟାକୁ ଆମେ ଜିରୋ କରିଦେଲା, वी आर लेफ्ट विथ द सेकेंड ऑर्डर, यार वैल्यू आसीगला i1 a स्क्वायर। तेबे एठी गुटे एक्स्ट्रा क्वांटिटी आछी देख डेल्टा। व्हाट इज दिस डेल्टा? दिस इज एक्चुअली द एम्पलीट्यूड ऑफ दिस साइनोसॉइडल न्यूटेशनल मोशन इन द यूनिट ऑफ थीटा एंगल, ओके। सो ए डेल्टा रो वैल्यू मध्य हमें बाहर करि परिबा, ओके। एठी जो स्टार मार्क दिया है एटा डेल्टा वैल्यू रो कैलकुलेशन एटा चली, ओके, बही रे। सो देखो thereafter we calculate the expectation value of phi dot which is in terms of delta like this, okay। और डेल्टा रो वैल्यू जेमती कहली mgl sin theta 1 by i1 a square हेबो, ओके। अगेन ए जो लाइन देछि लाइन रो तळे माने एटा सेही कैलकुलेशन कंटिन्यू करूछि, ओके। सो कंटिन्यू चली कैलकुलेशन देखो डेल्टा रो, ओके। एते डिटेल जीवा नहीं, केवल दिस इज ओनली फॉर योर नॉलेज पर्पस, ओके। सो expectation value phi dot ro asuchi mgl by i3 psi 0 dot, okay। so first top pai concluding remarks jodi dekhibo, since i1 a square is very greater than mgl, so delta jota ame dekhutila amplitude of nutation is small as inferred from equation 24। ଆଉ theta ର value which is equal to theta 0 plus delta minus delta cos omega t, so nutation is sinusoidal, that is simple harmonic, এটা তুমি জানিছো sinusoidal wave এই হিসাবে চলে, okay। then third point রে since i3 psi 0 dot equal to this much i1 a which is greater than or equal to mgl by a, so the expectation value of phi dot is small as inferred from equation 25, this one, thus the precession will be a slow one। and finally the fourth point, since omega theta equal to a, so the frequency of nutation is large, okay। so fast top when released from rest it precesses slowly and nutates simple harmonically with a large frequency and small amplitude। ए गोटे लाइन रे चारिटा जाको पॉइंट को ये लिखि देला, ओके। देन मु जेमति कहउतली गोटे सेकंड केस आछी एबे स्लीपिंग टॉप। तेबे एटा देखो ए जो ए लाइन रो तळे अगेन एटा डेल्टा रो ही से कैलकुलेशन कंटिन्यू करूची, ओके। फाइनली देखो एटा डेल्टा रो वैल्यू टा बाहर करूची, दिस वन, ओके। So coming back to the case of sleeping top. Sleeping top mane we consider a top which is initially spinning with its symmetry axis vertical. Okay, symmetry axis ta pura vertical achi. Okay, so ei case re p theta equal to p psi hela. Okay, again this is the effective potential energy. Ethi ame gote nela again a quantity alpha. Alpha ର value ଆମେ replace କରିଦେଲା like this. Okay, we move further. Again ଏଠି ଆମେ ଦେଖ for rapidly spinning top ଯେତେବେଳେ ବହୁତ ଜୋରରେ ସ୍ପିନ୍ କରୁଛି ନଟୁଟା, ତାହେଲେ ଆଲଫାର value will be less than half ହେବ and the spinning motion will be a stable one, and ୟାକୁ ଯଦି disturb କରିବା then it will exhibit a small nutation about the vertical axis. So the minimum spin angular velocity below which the top cannot spin stably about the vertical axis when alpha is equal to half, yaku ame bahar kari pariba omega minimum equal to square root of this quantity. And if initially omega z is equal to omega z dash, that is less than omega minimum, then the top will spin with its axis, that is vertically continuously. Okay, and therefore it is called a sleeping top. ସେଥିପାଇଁ ୟାକୁ sleeping top ବୋଲିକି କୁହାଯାଏ. Okay, because the top will spin with its axis vertically continuously ସେ ପୁରା ତାର axis ଟା vertical ରହୁଥିବ ଆଉ top ଟା ଏମିତି spin କରୁଥିବ, ତେଣୁ top କିଛି ବି ଆଉ movement ଦେଖଉନି ତା ମାନେ କହୁଛି. Okay, so it is a sleeping top. But when the friction reduces omega z below omega minimum, then it will again begin to wobble. Okay, so this is all about the case of a heavy symmetric top. Okay.
Thank you.